Everyone. In this video, we will introduce to you the SI system as well as accuracy, precision, and the scientific method. Measurements are very important for scientists because so much of their work is based on measurements and quantitative units, so we need to understand the measuring system that scientists use. First of all, when we say measurement, it refers to the assignment of a numerical value to an object's physical property. This is done in order to convey the relative size or magnitude of the property in question. For example, if I said this shoe was 10, you wouldn't actually know how long the shoe was because there would be no context to what the shoe represents. In fact, this number would only make sense if the number 10 had a unit of measure to go along with it. Most scientific data comes from measurements, so a standard is needed as it keeps data accurate and precise. There are three systems the scientists use: the SI system, the CGS system, and the English system. Today we'll only be focusing on the SI system, or as many like to call it, the International System of Units. This system, introduced in the 60s, is based on the metric system and is the most widely used system of measurement. It is comprised of 7 base units, with the 7 fundamental physical qualities being mass, length, time, temperature, luminous intensity, electric current, and amount of substance. Other than these 7, anything else is considered a derived unit. So what are the 7 units? For mass, it will be expressed in kilograms. For length, the meter. For time, seconds. For temperature, it's Kelvin. Luminous intensity is in candela. Electric current is ampere. And amount of substance is mole. All the other units that can come out of the SI system are considered derived units. Derived units are created from the fundamental units. They are complex units defined by the base units shown before. So for something like area, which uses the unit meters squared, it requires the meter to be defined. Therefore, it is a derived unit. Now that we understand a little bit more about derived units, feel free to take a look at some more units that you'll need for future reference. You may have noticed that some units of measure have a unique name like Newton or liter, while others have names that are based on their mathematical formula. Also note that some derived units require other derived units in order to be defined, which is the case for density and pressure. Now let us move on to the scientific method. The scientific method is a process for experimentation that is used to explore observations and answer questions. As proof that there is no one way to do science, different sources describe the steps of the scientific method in different ways. The steps don't always fall in the same order. But even when modified, the goal remains the same: to discover cause and effect relationships by asking questions, carefully gathering and examining the evidence, and seeing if all the available information can be combined into a logical answer. Let's go over the steps, shall we? The scientific method starts with an observation that piques curiosity, usually followed by the next step, which is to ask a question about what you've observed. The purpose of the question is to identify the problem in specific terms. Questions may usually start with how, what, who, when, where, and why. The third step would be to formulate a hypothesis, an educated guess about how things work. It is an attempt to answer your question with an explanation that can be tested. A good hypothesis allows you to make a prediction. If I do this, then this will happen. Fourth step would be to test the hypothesis by doing an experiment. In doing the testing, you need to consider the concepts of both precision and accuracy. Accuracy refers to the closeness of a value to the standard or known value. For example, if you obtain a weight of 3 kilograms for a given substance, but the actual or known weight is 10 kilograms, then your measurement is not accurate. Precision refers to the closeness of 2 or more variables to each other. For example, if you weigh a given substance 5 times and get 3 kilograms each time, then your measurement is very precise. Considering these two concepts may thus identify whether or not your hypothesis is supported. Once your experiment is complete, the next step would be to collect your measurements and analyze whether or not they support your hypotheses. The amount of analysis required to come to a satisfactory conclusion can vary tremendously. Sometimes sophisticated statistical tools have to be used to analyze data. Either way, The ultimate goal is to prove or disprove the hypotheses, and in doing so, answer the original question. The end of this process would be to draw a conclusion, a statement of whether the original hypothesis was supported or refuted by the observations gathered. Whether you are doing a classroom science activity, independent research, or any other hands-on science inquiry, understanding the steps of the scientific method will help you focus your scientific question and work through your observations and data to answer the question as well as possible. Thank you for listening and learning with us. Until next time!